Hello everybody and welcome back to Boiler 1. Today we are going to do something a little different. We are going to play around with Solidworks a little bit, some 3D modeling. Hopefully I'm allowed to do this with the program. But I'll get back to the coaster constant hopefully next week. But this week I would like to show you guys a new little thing that might be a series if I can. And today I'd like to make you a 3D solid of constant width. Like this one I already had made. It was made out of a rounded pentagon called a rouleau pentagon that was swept out in 3D using a solid of rotation. And the special thing about that is that whatever angle you rotate it at, it will always have the same width, which means it'll roll smoothly between, like say if you were to place a few on a table or the floor or something and put a board on top of it, you could slide it along and it would roll smoothly. So this one was using a pentagon. What I did was I made a pentagon. I first made a pentagon and then I rounded the faces so that each face was an arc centered around the opposite corner. And then I swept out a solid of rotation using the Revolve feature in Solidworks. So I already made this pentagon, and I think this time, for this video, I'd like to show you guys the same process using a heptagon, or a 7-sided shape. Now you can make this with any kind of, any odd numbered side shape, so any shape that has an odd number of sides. So a triangle, a pentagon, a heptagon, a nonagon, and so forth. It won't work with an even number of sides because the sides are not opposite of other points, so you can't really make a defined arc that's even with the opposite side, or that stays equal. Okay, so the first thing we're going to do in order to make the shape is start a two-dimensional sketch. We'll use the front plane so that we make sure it's facing. It doesn't really matter which plane we use, but we're going to use that. Now, I could draw out each line separately and then create a lattice structure from that, but there's a lazy way to do it using a polygon. So first we have to draw the center, and then simply draw out the radius. And we'll make sure that we'll make it vertical so that way we can see. And this is all going to be construction line, so that means we won't really need to use it. And now we have our 7-sided shape that we will begin with. And then we need to define a diameter for this, so we're going to draw another construction line from one of the points to one of the opposite points, and simply type in a value using Smart Dimension. So now we can change the dimension. Let's say 40 millimeters. We have to zoom in a little bit now because it got smaller. But the reason I chose 40 millimeters is that it is now the same diameter as a table tennis ball, which means that they can use it with table tennis balls to show the difference. And they'll be the same size, which means if you were to do demonstrations, you could use them to demonstrate the similarities. So, the next step is to make the defined arcs, which we'll use the handy arc tool. We will choose center point arc, because we know that the center point of each arc is going to be each vertex of the polygon, and the arc endpoints will be defined by the opposite side of each point. Oh wait. on each point and sweep out a little arc, a happy little arc, which with each turn each side. But now you can see that the sketch is all still blue, which means that it is not completely defined. When it's completely defined, it'll turn black. So this little inscribed circle is black, which means that it can't be changed, but the rest can. And if you click on them without being in any other tool, you can drag and move them. You can click on parts of the sketch to see how they can still move. In this case, I don't know what it wants from me. So what we're going to do next is draw a line that will connect the top vertex and the center, and we'll make an infinite length on it so that it'll be a good rotation axis so that we can sweep out the three-dimensional shape. And the final thing we need to do is we need to make a solid line that defines the halfway point of the shape. So that way we can use each half to sweep out the circle. Because otherwise Solidworks doesn't really know that it's a full shape that's supposed to be kind of rotated around itself. And then for the final step, we just need to revolve this shape. So we will revolve this shape around this axis of revolution, and it'll create a 360-degree rotation, which is exactly what we need. And now we have it, our seven-sided solid of constant width. You can rotate it, and whatever direction you rotate it, it'll always be the same diameter from the top end to the bottom end. Isn't that amazing? I think it is. Thank you guys for watching. Comment if you'd like to see any more videos like this, and comment any other suggestions you have for future videos. This is Boiler 1. Thank you all for watching. I'll see you in the next video.